Okay, for the C++ side of things, we have about 12 code files to go over, so we're in it for the long haul. For every header file, you'll want this top portion here. This is to make sure that if the header is included more than once, the class does not get included more than once, because otherwise you'll have problems. I didn't really rename this default one, but it's the main menu, just trust me. I have, however, moved this in here, the using namespace, because I use Cocos objects quite a bit in the class header. Most of this is the same as the default Cocos classes. Here you see that I've added some more playbacks for some more buttons. I have a play callback and credits callback for those two buttons. I have a callback for when the user presses the back button on their device called onKeyReleased. It takes an event keyboard key code and an event. Next we have the actual class. I include headers for the different scenes you can transition into. So here you can see I have the game scene and the credits scene. And I also include simple audio engine because scenes are pushed onto a stack and this main menu scene is always existing. So for this reason, init is only called once, and I do things for initial setup here. So one of the things I do is that I will preload the sounds I will be using, which you'll see in a moment. But here, this is standard init code, so I will skip by this. This is essentially getting the size and origin of the screen and putting in the power button you see at the bottom right corner. But here's where the new code starts. Right here, we have the main menu. We have the header label, which is a label TTF. And then we also have the instructions here and the items. The items are menu item font types, which will be added to a menu in a little bit. And you use a CC callback 1 because the callback will only be taking one argument, so I pass in the callback and the object that has this callback function, which of course is this. And then I also do that for credits. Then we want to set the position of all these items, which, as you can see, I divide everything up evenly. Everything is centered because, unlike in Unity and Cocos, the point of origin is the center of the object, not the top left corner. So here you can see I centered all the objects XYs using visible size width, and then I split everything up evenly by dividing the spaces into 5 parts and putting an object in each one. Counting vertical wise starts from the bottom, so that's why the numbers are backwards here. So a bigger Y direction is farther up top. And then once I've done that, then you add them to the actual scene. So this is what we do here. We take the objects we just created and add them to the scene. Since they're part of the game and not the background, I set their Z order to 1. Then here we have the menu we create, which is a pointer, a menu pointer, and we have 2 items, and then we want to stop, so I put a null here. And for set position, we want it to be in the same place that the menu items are positioned, so I just pass in 0, because we don't want to offset anything. Then we add the main menu. Pass this code. Now we want to preload our sound effect. So we call the simple audio engine and get its instance. Then, because I'm a very loud person, unfortunately, when making that sound, I set the effects volume to 1/4 of its normal limit so that I don't blow out your ears. And then we preload the sound effect. You can do this. This is also a good place to preload background music if you have that. And then, of course, I want to start checking for the back button, so I set keypad enabled to true. And then we have our callbacks. We get the scene that we're going to, and then we push the scene onto the stack. That's what both of these functions are doing. And on key release, since we are at the main menu, we want to release the resources for the audio engine, and then we want to end the program. And then down here is just the standard code for the power button. Next I will show game state. This is not a scene, this is just a persistent singleton class so that it can be checked everywhere because there are multiple scenes that use it. First, we have our singleton instance that we have to declare. The only way to get it is get instance. If it's not declared for the first time, the first line will do just that, and then we return that instance. And then there are just a few variables here. Result is whether the game is still going, you win or you lose. And then the player score. Pause, I did not exactly implement pausing. I will show later how you can actually implement pausing into the game. And then down here, you want to make these private so that you can't access the game state outside of get instance. Next, I'll go over other classes before I cover the scene that they're in. Next is S-tile. These are the tiles that the player was standing on that disintegrate over time. Similar to the other Cocos2d-x classes, I use a create method that you can just call to create these things. Pretty much all of these classes have a sprite and a sprite body assigned to them. And here is disintegrate. When we want to remove the object, we want to make sure to remove the sprite body so that the player can no longer stand on it. So we call remove from world, and then we want to not display the sprite anymore, so we remove from parent and clean up. Then here we have our constructor, where we create the sprite with the appropriate file name. Then we create the sprite body, which is just a box, and we want to make sure that it's the same size as the sprite, so we get content size to do that. Then physics material, the numbers represent density, restitution, which is basically bounciness, and since I don't want bounciness, I set it to 0. And then the last one's friction. And then this one, because they're just floating in air, we don't want them bouncing around, we want them to stay in place. So these tiles have their set dynamic set to false. So now there'll be static bodies instead of dynamic bodies. And then once we've set all the properties, then we want to make sure the sprite has that body. So we set its physics body to the sprite body. Next we will cover the player. Same idea, create method, sprite and sprite body. We have an origin. I use the origin vector to determine if you're standing in your original spot or not. And then I have a boolean for whether the player is moving or not. Is at origin. You see I have a float defined here. This is because it's not a good idea to check if the player's in the exact position, because with the physics engine they may bounce around a bit. So I indicate a degree of error saying this is how close you have to be considered good enough that you're at origin. So the default I use is 10 pixels. And so this checks if the distance between the origin and the sprite's actual position is less than this degree of error. And I do something similar with is moving. I use 1. It probably should be higher than that because if you noticed, it fidgets a bit while standing. Because the velocity is never truly at 0. Just another thing about the physics engine. So I use more degree of error here. I get the velocity of the sprite body, its Y position, because since I'm only jumping up and down, I don't care about X. And then based on what the error value is set to, I check if the velocity is outside that range. If it is, then the player must be moving. Then here we have jump. If the player's at the origin and he's not moving, that means he was originally in a standing position and he's able to jump. And if the velocity value is greater than 0, then we're going to set that velocity. And basically that velocity is how high the player is going to jump. Basically at what speed. And so since he's only jumping straight up, the X value remains at 0 when I set velocity, and I just set it to Y. Now here we have the constructor. We set the sprite. Default position is standing. So the position is basically where the player's feet are. That's the position you would pass in here. But because positions should be at the sprite center, I add half the height to get the correct position. Then I set that to the player's origin and set the sprite position. Then I create the sprite body, which, just to simplify things, I just created a box. You can create a custom physics body out of many shapes, but just for time's sake, I just created a box. For velocity limit, because some people can get really loud, I don't want the player to shoot off into the stratosphere. So I set a velocity limit to make sure you can't go too fast. And here I use 900. And as I mentioned before, using this as a 2D platformer is a very bad idea, because sometimes when you bounce, you might turn. You could see I tried to limit that by limiting angular velocity to 0 and increasing the angular dampening to max. But really, you should try to avoid the physics engine as much as possible. But this is just a demonstration. Next, we have collisions. The collision bit mask I use as 1 so that I can differentiate between the player and the collectibles. And the contact test bit mask is 1 so that I can say, hey, I want to check for collisions on this object. Now that that's all done, I set the physics body and make sure that moving is false by default because we're standing. Next, we'll go over the collectibles. Each collectible has a type. Technically, I could create more types like, say, styrofoam cups, but for this program, all I used were the packing styrofoam. So really, there's only one type, but this setup allows for multiple types. It's basically just part of a file name. And then there's the score value and how high it should spawn. So you could have, say, multiple rows of items passing by, and that height allows you to do that. Here we have Boolean for collected. The reason why I have a Boolean for this I will show later. Disappear, in case, say, it goes off screen, we don't want to give score for that. So disappear is separate from collect. And we just remove it from the scene like we do with the tiles. And then we have collect, where we increase the player's score, and then we make the item disappear. Now let's look at the constructor. Here we have the file name, the beginning is collectible, and then that's followed by whatever the collect type is, and finally that it's a PNG file. Then we create that sprite, and we want to get the visible size width, and add half of the sprite width, so that way the item starts just off screen so that you can see it moving in. And then of course we want to set the height to the height we passed in. Then we want to create our physics body, set it to the sprite size, the standard physics material that I showed. I'm setting the velocity limit to be the same. And because these objects are flying, I don't want gravity to affect them, so I disable gravity on these objects, set a collision bit mask of 2 to differentiate from the player, check for a contact test, and then I set the sprite body, the points it'll reward, and of course it hasn't been collected yet, so that's false. Okay, now I will finally cover the game scene. Right here, I check to make sure that this is on Android, because only Android is using the native call, and for that we have the current volume that has been obtained from the Java side. Then other than that, we have our update game loop here, which I'll show how to define later, but this is the delta time, the time since the last update, our on key release, and here we have private variables. We have our physics world, which is where all the physics happen. We set the world initially, which you'll see later. Here I have the debug label, which you might have seen in the top left corner during the gameplay. This basically displays the current amplitude that is obtained, just for debug purposes. This is the timer for how long you last, which was in the top right corner. The time in seconds, and then the actual label that displays it. This is the delta time. Because timer is only in seconds, I accumulate the delta time until it reaches 1, and then I change the timer value after that. Tiles, this is the container for all 5 tiles. Here's the player object stored, and then I have up to 6 collectibles on the screen at once. And then we have our function here for checking a collision between the player and the collectibles.